So let's work through a little model that allows firms to choose between two different types of inputs when they're producing their output. So our two inputs here are number of workers along the horizontal axis and tons of coal along the vertical axis. And you can see we've got a number of different production technologies here in order to produce the same amount of output. So we don't know what that output is, we don't know how much it is, we just know that these combinations allow us to produce the same amount of output. So we can use at point A, we can use 1 worker and 6 tons of coal. At point B, we can use 4 workers and 2 tons of coal, etc. So we can graph those in our model, and we can see that some of these options are not so good. So let's look at point C and point A, for example. At point C, we have 3 workers and 7 tons of coal. But at point A, we have 1 worker and 6 tons of coal. Fewer workers and fewer tons of coal producing the same amount of output. So point C is no good. We don't want to use point C. We'd rather use point A. Similarly, point D, which uses 5 workers and 5 tons of coal, is more of both than point B, which is only 4 workers and 2 tons of coal. So D is dominated by B. Now, in terms of A, B, and E, our 3 remaining points, we don't really know which one is better. All right? A uses fewer workers and more coal. B uses a medium amount of workers and less coal. And E uses just a ton of coal and a whole lot of workers. So we don't know which one is best yet. What we do know is that C is dominated by A. We can draw a box around A going out from the origin, right? And the same with D being dominated by B. And point E is neither dominated nor dominates. Which one we choose will actually depend on the cost. So let's think about that. Let's imagine that the wage is 10 pounds and the cost of coal is 20 pounds. All of these examples are English, that's why we're using pounds instead of dollars. So at point B, we need 4 workers. We pay them 10 pounds, that's 40 pounds. We need 2 tons of coal, 2 times 20 is 40. 40 plus 40 is 80. At point A, we need 1 worker, it costs us 10 pounds, but we need 20 tons of coal, that costs us 120 pounds, and so that costs 130 pounds. At point E, we need 10 workers, that's 100 pounds, 10 times 10, plus 20 pounds for 1 ton of coal, so that's 120. So in this case, point B is our lowest cost, right? And so if we were the firm choosing between points A, B, and E, we would choose point B because they all produce, in this case, 100 meters of cloth, right? We're getting the same output, but B is cheaper, so we would produce B. We can draw a curve, or a line, really, that goes through point B that represents all of the points where the cost is the same. We call that an isocost curve. Iso just means the same, cost means, well, cost. And so all the points along that line, JH, all cost 80 pounds, okay? The slope of that curve is just going to be the negative of the wage, which is what the workers cost, divided by the price of coal, which is what the coal costs, or in this case, 10 divided by 20, or 1/2. It's negative, right? It slopes downward. It has a negative slope. Occasionally, you may find an economist that just ignores that negative number and just says, hey, it's got a slope of 1/2, because we know it's negative. We're assuming it's negative. All right, so let's think about another example. Let's say that coal gets a whole lot cheaper. Wages stay the same, they're still 10 pounds, but coal is now only 5 pounds per ton instead of 20 pounds per ton. So now B costs 40 plus 10, that should be 50. A costs 1 plus 10, so 1 times 10 is 10. 6 times 5 is 30, that's 40. And then E, 10 times 10 is 100, plus 5 is 105. So A, in this case, is our low-cost provider. So we can cross out that 40 because that should really be 50. So no worries. All right. I have to erase that. We can draw now this isocost curve that goes through point A and gives us an isocost curve of 40 pounds. And this point B should really be over here, right? That's where our point B was before. And that isocost curve that goes through point B would be 50 pounds. It would be parallel to the one we just drew because we're drawing it for the same cost, 10 pounds for a wage and 5 pounds for coal. But the point going through A is closer to the origin and therefore is cheaper. All right. We should erase that. There we go. And now you see our slope is minus 10 over 5. It's minus 2. It's much steeper in this case than the slope was before. So we can draw those curves. We can see that when the cost of coal changes, our isocost curve changes and our lowest cost alternative changes. So as the price of coal fell in Britain, firms wanted to use more coal and less labor because labor was still pretty expensive. And so they might move from point B, right, here it's in the right place at 4 workers and 2 tons of coal, to point A at 6 tons of coal and only 1 worker. That's that curve we just drew, right? That goes through point B. It would cost 50 pounds instead of 40 pounds, and so it would be more expensive. Firms wouldn't want to do it.